So during this the lecture session on acceptance sampling, I am going to discuss a number of issues and concepts related to acceptance sampling. The first one I am going to discuss, that is the performance measures of the sampling plans. You come across different types of sampling plans, and when you start using them, how do you come to know that whether the given sampling plan is performing well or not. So those are the issues we must be dealing with, and here in this context we propose two types of curves, or the two types of performance measures. The first one is the OC curve, or the operating characteristics curve, that we are going to discuss, and we also can propose the ASN curve. ASN stands for average sample number. So once we discuss these measures, then you also must know how to construct an OC curve and how to construct an ASN curve. Concept of rectifying inspection, this concept is widely used, and there could be few numerical exercises we will be referring to. Now we have already mentioned that depending on the type of data you are referring to, you select a particular sampling plan. So that is this classification based on the type of data you collect or you use. So whenever you collect attributes data, and so you need to use the attribute sampling plans. That means under this category you have a host of sampling plans, and one or more such sampling plans you have to use. So the first thing you must know that what is the working of such a sampling plan. So under attribute sampling plans, there are the varieties of sampling plans. We may opt for single sampling plan, we may opt for double sampling plan, and we also may opt for multiple sampling plan. Now what is the working of such plans? So if you deal with the single sampling plan, what you do, that means in this plan, inspection result as obtained from one sample of a specific sample size drawn from the lot is used to make a decision to accept or to reject the lot. Is it okay? That means the permissible number of the sample to be drawn from the lot is just one. So that's why it is referred to the single sampling plan. So if capital N is the lot size or the batch size, the small n is equals to the sample size, the acceptance number is equals to small c, the number of non-conforming units in the sample is x, a random variable. That means when you get a sample from the lot, you start inspecting each and every unit in the sample. That means 100% inspection of the sample units. Now you just count that how many non-conforming units occurring in the sample. So this is a variable. So obviously this is specified as x, and x is a random variable. It could be 0, it could be 1, it could be 2, or it could be 3, so any number. So that's why it is referred to a random variable. And for this particular case, when you deal with attribute sampling plan, obviously this random variable is a discrete random variable. That means only you get the integer values. Now this lot is accepted if x is less than equals to c. That means what is the c? C is the acceptance number. This is one of the parameters of a sampling plan, it's acceptance number, and the lot is rejected if the actual number of non-conforming say the units in the sample is greater than the small c. So what are the parameters of such a sampling plan called single sampling plan? That is n and c. given capital N, that is the lot size. So what is an example? N is 2000, capital N is 2000, small is just 25. That means the remaining 1975 units you don't need to inspect, only 25 units you inspect, and suppose the acceptance number is equals to 1. Obviously later on when you discuss the design of the sampling plan, you will come to know say under a given condition, under a given this is stipulated condition, how to determine how do you select the values of small n and select the value of small c given a lot size. Is it okay? Capital N. You may opt for a double sampling plan. So what is a double sampling plan? That means in the double sampling plan, if you opt for the maximum number of say the samples you are allowed to draw from the lot before you take a decision regarding lot acceptance or lot rejection is 2. That's why it is referred to as the double sampling plan. So in this plan, a maximum of 2 samples is allowed to be drawn from the lot for making a decisions on lot acceptance or lot rejection. The point I have mentioned. If capital N is the lot size, N1 is the first sample size, that means there will be 2 samples, and for each sample you have to specify the sample size. So N1 is the first sample size. The acceptance number for the first sample is small c1. R1 is equals to the rejection number for the first sample. N2 is the second sample size. The acceptance number for the second sample is C2. R2 is the rejection number for the second sample. Then the decision rules are as follows. Okay. A random sample of N1 is drawn from the lot, that is the first sample of size N1. N1 could be 25. If actual number of non-conforming units in N1 is x1, so x1 is a random variable, and if x1 is less than equals to c1, the lot is accepted. That means you do not need to draw the second sample. From the results you obtain from the first sample, you can take a decision on lot acceptance. Or suppose this random variable, that is x1, that means actual number of non-conforming units in the first sample is greater than or equals to R1, that is the rejection number on the first sample, the lot is rejected. Okay, so they don't need to go to the second stage. But if x1 is greater than c1 but less than R1, that means it lies between say c1 and R1. Suppose c1 is 1 and R1 is 4. So if you get a value of x1 as 2 or x1 as 3, so you can't take a decision. So for taking a decision, now you are allowed to draw the second sample, and while you draw the second sample size is N2. Is it clear? And then what you do, then again you try to find out how many non-conforming units in the second sample. If x1 is greater than c1 but less than R1, okay, the decision cannot be taken based on the first sample, and the second sample of size N2 is drawn from the lot. Is it okay? So this point I have already mentioned. If the actual number of non-conforming units in N2, that means in the second sample, is x2, so that is also a random variable. It varies from one sample to another. The lot is accepted if x1 plus x2 is less than equals to C2. That means what is C2? C2 is basically the acceptance number for the combined sample. And the lot is rejected if x1 plus x2 is greater than equals to R2. That means what is R2? R2 is basically the rejection number for the combined sample. So what is the combined number samples? That means x1 is basically the actual number of non-conforming units in the first samples. You cannot take a decision based on the number which you get in the first sample. So that's why you have drawn the second sample. Again, in the second sample you start counting the number of non-conforming units, and that value is x2. Now you add x1 plus x2. If you find that x1 plus x2 is greater than or equals to R2, then that is the rejection number for the combined sample. You are going to reject the lot. But if you find x1 plus x2 is less than or equals to C2, okay, then you are going to say accept the lot at the second stage. Obviously, you cannot remain indecisive at the second stage. So that's why either you have to accept or you have to reject when you go to the second stage. So that's why the R2 is equals to C2 plus 1. Is it okay? Example, like say given capital N, that is the lot size is 5000, N1 is 50. That means the 50 units are drawn from say the lot, and then you start counting the number of non-conforming units. If the non-conforming units is less than or equals to 1, then you are going to accept the lot. If the number of non-conforming units in the first sample is greater than or equals to 4, then you are going to reject the lot. Supposing the value you get, that means the number of non-conforming units in the lot in the first sample is either 2 or 3, then obviously you cannot take a decision. So you have to draw the second sample. Suppose the second sample size is 100. Then again what you do, that means now again out of 100 units in the second sample, how many are non-conforming? So that you count. So that is x2. Then you consider the number of non-conforming over here and the number of non-conforming over here. That means you add them, and then the total number of non-conforming in the combined sample you get N1 plus N2, and then if this total number is less than or equals to 5, then you are going to accept the lot. But if it is greater than 5, that is 6 or more, then you are going to reject the lot. So this is the working of a double sampling plan. So in general, what do you find when you design a double sampling plan? What do you find that usually the first sample size is not equal to the second sample size. That's why I have written N1 is not equals to N2. Is it okay when you design the sampling plan? But however, for simplification, what you try to do in many cases you will find when you refer to the the standardized sampling plans. Okay, so what you need to do in any design exercise, you go for the standardizations, you go for simplifications. So here also the same norms we follow, and that's why in many cases we hold N1 is equal to N2. N1 could be is equal to N2, or sometimes the second sample size is twice of the first sample size, 2N1. Hence there is a possibility of accepting the lot based on inspection of the first sample only. Is it clear? So there is a possibility, or rejecting the lot based on the inspection of the first sample only, accepting the lot based on both first and the second samples. Is it okay? Or rejecting the lot based on both first and the second samples. So these are the four possibilities we have, and while we explain the working of a double sampling plan, we have highlighted all these four possibilities. The corresponding probabilities are noted as PA1, P subscript A1, P, that means this is the probability of accepting the lot based on the first sample. P subscript R1, it means the probability of rejecting the lot based on the first sample. P subscript A2, that means the probability of acceptance based on the first and the second sample. You have to go to the second stage. And similarly, P subscript R2 means the probability of rejecting the lot based on the second sample, combined sample. So these are the four notations. So obviously when you add all these 4 probabilities, so that the sum total will be 1, and later on you will come to know in a given case how to compute the value of all these probabilities. Is it okay? And only when against a particular say the lot input quality you are able to say compute these probabilities, possibly you can determine or you can measure the performance say the performance measure for a given sampling plan. Now in many cases there could be extension of say the double sampling plan, and whenever the maximum number of samples you are allowed to draw from the lot for making a decisions regarding lot acceptance or lot rejection, this maximum number the permissible the number is more than 2, then we refer to such a sampling plan as a multiple sampling plan. So how do you explain the working of a multiple sampling plan? So it is an extension of the double sampling plan. The point already I have mentioned. In general, a maximum of the number of samples, a maximum of the number of samples, the 2, a maximum of say a 2 number of samples, or say more than 2 number of samples are allowed to be drawn from the lot for making a decisions on lot acceptance. So here a maximum of more than 2 number of samples. The working rule is similar to that of double sampling plan. So here is an example. Given the lot size as 4000 units in the lot, N1 equals to 20, C1 equals to 0, R2 equals to 2, N2 equals to 20, C2 is equals to 1, R2 equals to 3, N3 is equals to 20, C3 is equals to 2, and R3 is equals to 4, N4 is equals to 20, C4 is equals to 3, and R4 equals to 4. So how do you explain the working of such a sampling plan? That means from the lot of size 4000, first you draw a sample of size 20, and then you check what is the number of non-conforming in the first sample. If it is 0, you are going to accept the lot. You don't need to go to the second stage or third stage or the fourth stage. And if you find that the number of non-conforming in the first sample is greater than or equals to 2, then you are going to reject. You don't need to go to the second stage. If you find it is 1, obviously you cannot take a decision based on the first sample information. So you don't need to draw the second sample. The second sample is 20. That means now you start counting the number of non-conforming units in 20. So already you have this data with the first sample of 20 units. So the total number of non-conforming units in the combined sample, first and second, if it is less than or equals to 1, then you are going to accept the lot. If it is greater than or equals to 3, you are going to reject the lot. But if it is 2, then you can't take a decision. So you need to draw the third sample. The third sample is again 20 units you draw from the lot, and you start counting the number of non-conforming units. So now you have the first sample, second sample, and the third sample. So the total number of non-conforming units in the 3 samples will be known, and if this number is less than or equals to 2, you are going to accept the lot at the third stage. If this number is greater than or equals to 4, you are going to reject the lot at the third stage. But if it is 3, say between 2 and 4, you cannot take a decisions. So you have to draw the fourth sample, and the fourth sample size is again you have specified as 20. So again you count the number of non-conforming units in the fourth sample. So now you have all the 4 samples and the total number of non-conforming units in all the 4 samples that you come to know. If this total number of non-conforming units in all the 4 samples is less than or equals to 3, you are going to accept the lot. Otherwise, if it is 4 or more, is it okay? You are going to reject the lot. So this is the procedure. So here what we have assumed that the maximum number of so the samples you are allowed to draw from the lot for making a decisions regarding lot acceptance or lot rejection is 4. So this is just an example. The decisions rules at each stage can be set following the working norms of the double sampling plan. Is it okay? This already I have explained. At each of the 4 stages, there are probabilities of accepting or rejecting the lot, like in the previous case. Is it okay? And you need to use the notations of such probabilities accordingly. It is to be noted that the probabilities of lot acceptance or lot rejections can be computed against incoming lot quality. So the incoming lot quality, that means whenever you get a lot, now you must be able to specify its quality. Like say suppose when you deal with the attributes case, that means there could be several possibilities, several values of the possible values of incoming lot quality, and this for the attributes data when you deal with this incoming lot quality is specified as proportion non-conforming. Now there is a concept of equivalence among sampling plans. Like we say in a given situation you may opt for a single sampling plan, or you may opt for a double sampling plan, or you may opt for a multiple sampling plan. Choice is yours. Now the question is that so how do you say that a single sampling plan is equivalent to a double sampling plan and also equivalent to a multiple sampling plan? That means the choice is yours. You may opt for say that single sampling plan, double sampling plan, or multiple sampling plans, but make sure that whatever the sampling plan you use, there's impact that you felt, that you have. Is it okay? In terms of the performance you get, that is acceptable to you, and almost the same level of performance you get. So then only you say that all these 3 types of sampling plans are equivalent to one another. While designing a sampling plan to meet specific objectives, essentially an exercise to determine the parameter values under a set of constraints or stipulated conditions. Is it okay? So under the set of constraints or the stipulated conditions. So that we'll do when when we discuss the design of a sampling plan. You may select an SSP, that is single sampling plan, or its equivalent double sampling plan, or its equivalent multiple sampling plan. Is it okay? Like MSP. In this context, how do you define an equivalent double or multiple sampling plan with a single sampling plan? So this is the key questions we have. Now, a single sampling plan is considered equivalent if to a double sampling plan the probability of accepting a lot for both types of sampling plans is same for a given incoming lot quality. That means what we are saying, that the single plan is considered equivalent to a double sampling plan if the probability of accepting a lot for both the types of sampling plans is same for a given incoming lot quality. Is it clear? I think this is the definition of equivalence between the 2 sampling plans or among 3 or more sampling plans that we use. There is another concept of say the curtailment in inspection for say samples. In general, we assume that there is 100% inspection for a sample. This we have been saying. That means suppose a capital N is the lot size and the sample size is a small n, and you are inspecting unless otherwise stated that you need to inspect each and every item in the sample before you take a decision. So this is 100% inspection for a sample, usually the case. However, before 100% inspection of the units in a sample is over, okay, you start inspecting each and every item, and you know what is the acceptance number or what is the rejection number. You may observe that the number of non-conforming units is greater than or equal to the rejection number. That means suppose the sample size is 25. You start inspecting say all the units one by one. So the first unit, second unit, third unit, fourth unit, and so on. What do you find? That suppose your inspection number is say suppose your acceptance number is 2. When you say inspect the 10th unit, you find that the acceptance number, okay, has the total number of units that you have come across. Is it okay? That is more than the acceptance number. Okay, and suppose it's a single sampling plan. What do? That means you don't need to inspect the remaining 15 units. So immediately you can take a decision that while I inspect the 10th unit, only the 10 units I have inspected, and then I have seen that the 10th unit is the third the non-conforming unit, whereas the acceptance number is 2. So immediately I am going to reject this. I don't need to they inspect the remaining 50 units. If you follow this rule, if you follow this norm, so this is referred to as the curtailment of inspection. So hence, without going for inspecting the remaining units in the sample, in this case the 15 remaining units, you are not going to inspect. You may stop inspection and take a decision to reject the lot. This condition may occur at any stage of a double or multiple sampling plan also. Are you getting my point? So this concept is referred to as curtailment of inspection in acceptance sampling. So in many cases, in a practical situation, or in a real say world situations, many a time the management may prefer to opt for curtailment of inspection, because you have to take a decision immediately if there is an urgency. This is used to reduce the cost and took a decision at the earliest. Okay. However, it may lead to incorrect conclusion on the quality of the lot as less information is obtained. That is obvious in fact, but that is not the main purpose. That means here is a case where you have to take decisions immediately. So for those cases you may opt for curtailment of inspection. What is rectifying inspection? Rectifying inspection is also you should be aware of. And if you adopt rectifying inspection in your system, then certain the performance measures you need to prescribe. Is it okay? So what is this rectifying inspection? Let me elaborate. In many situations, in order to improve a supplier's performance, the rejected lots are sent back to the supplier for rectification. Is it okay? So decisions could be rejection. So what you said, that the rejected lot is sent back to the suppliers. So on receipt of a rejected lot, okay, that means it is referred to as the return supplier, and this is a very the serious case in most of the organizations. If your the orders are your supplies are returned to you because of some quality problems, so immediately it becomes an emergency situation. So what do you do? On receipt of a rejected lot, the supplier goes for 100% inspection. So now he is not going to take any risk. So he goes for 100% inspection of the lot, identifies all the non-conforming units in the lot. Is it okay? And replaces them with conforming units. The lot is then made free of non-conforming units. This process is known as the rectifying inspection. Is it okay? So many a time what you need to do when you deal with the stream of lots or series of lots, in order to improve the output quality, you may opt for say rectifying inspection. Through this process, the output quality gets improved and the performance of the supplier is expected to improve. Is it okay? While you go for lot by lot acceptance sampling, you may come across two possible situations as far as availability of a lot is concerned. Situation 1, the lot you receive is an isolated lot of finite size. That means just a one-time occurrence, one lot. Situation 2, the lot you receive is one of several or a series of lots, or a stream of lots. Lot size is at least the 10 times more than the sample size, arriving in a sequence for inspection. So this is the condition. That means the lot size is at least 10 times more than the sample size. While determining the probability of accepting a lot through acceptance sampling procedure for a given value of incoming lot quality, the distributional assumptions regarding the random variable, that means the actual number of non-conforming units in a sample, as we have already pointed out, that is referred to as x1 or x or x1, x2 for the double sampling plans. For the x, it is referred to as for the single sampling plan. So there could be different kinds of distributional assumptions regarding x. So incoming lot quality is specified as proportion non-conforming. Okay. So in the situation 1, if you come across, that means isolated single, say the single lot case, probability of loss acceptance for a given number of non-conforming units D. Here what we assume that the distribution of x, that is the number of non-conforming, it can be assumed to be hypergeometric function, and this is the probability mass function for the hypergeometric distribution, that is D combination x n minus D combination n minus small x divided by n c n, where D is the number of non-conforming units in the lot. Is it okay? Actual number, not the proportion. The probability of lot acceptances PA is given as, that means C is the acceptance number, that means sigma x equals to 0 to C Px for a single sampling plan. Similarly, in the situation 2, that means how do you compute the probability of lot acceptance for a given lot proportion non-conforming units P? That means the distribution of x is assumed to be binomial, and this is the probability mass function for the binomial distribution. That means NCx p to the power x into 1 minus p to the power n minus x, where p is the lot proportion non-conforming. The probability of lot acceptance PS, similarly you calculate. That means the probability of this in both the situations, a Poisson distribution may be used as an approximation to the binomial or the hypergeometric distribution. So this is the probability mass functions for the Poisson distribution, that is e to the power minus lambda to the power x by factorial x, and the same the formulation you use to compute probability of acceptance. Is it okay? Now here what we try to do, that means we'll be referring to the performance measures of the sampling plans, and there could be two types of situations, like say in a normal situation, or there could be a situation where the rectifying inspection is used. So what do you mean by the normal situation? That means where there is no rectifying inspection. And what is if you have a special situation, that means rectifying inspection is enforced, then what could be the performance measures? So I just conclude these lecture sessions by referring to 4 types of performance measures. So 4 performance measures. Now these operating characteristics curves and average sample number curves. So these 2 performance measures you suggest when there is no rectifying inspection. We have already explained what is a rectifying inspection, whereas when the rectifying inspection is enforced, these 2 performance measures you opt for, that means average outgoing quality curve that you have to construct, and similarly average total inspection curve. So these 2 measures are used in special situations where rectifying inspection is enforced. So I conclude these sessions. In the subsequent lecture sessions, we'll be discussing all these performance measures one by one.